All right, you have things mostly ready?
I think we're live, yeah. So
all right.
We're good.
All right. Good afternoon. Thank you all so much for being here. So my name is Julia Sohi, and I am a lover of the R language, and I hope you all are too. So I'm a data scientist at Stack Overflow, and Salt Lake City and Utah have had an R user group that has been meeting up with you, and it's been about 6 months since we've had a meeting, and so we're gonna, our goal is to start having approximately monthly meetings in the around downtown-ish area. That is our goal, and so this is the first one of what we hope to have be productive, interesting, fun meetings as we grow the community of people who use the R language for statistics and data science and all kinds of fun, interesting things in the Salt Lake City, University of Utah area. So I would love to say hi to you if I don't know who you are. I'm one of the organizers here. Andrew is up at the University of Utah and is an organizer. Mark is at Intermountain Healthcare and is one of the organizers here, so say hello to us. So welcome. Some months we may have lunch. Some months we may have cookies. We may talk about time of day as things go along. If you have any strong opinions, talk to one of us. If you are at a company that may be interested in acting as a sponsor or a host, supporting lunch or anything like that, definitely get in touch. Today, our speaker is Andrew, who is going to be talking to us about profiling and debugging your R code. So let's get started.
Thank you, Julia. I want to especially thank Julia because, as if you've been with us in years past, I was doing a lot of this by myself. Thank you, Julia, for stepping up and kicking my butt and getting things going again. So as life gets busy, this is one of the things that has that I have slacked off on. So I'm here to make amends. So let me get a quick survey of what kind of experience I've got here. So how many people programmed with R before? Good. Okay, how many people write their own functions? Awesome. How many people have debugged before? How many people have profiled before? How many people have debugged in other languages? Okay, who knows what profiling is? Okay. All right, so we're going to be talking about debugging and profiling. Debugging is finding the bugs in the code, and I just found out that it is actually urban legend that the phrase bug in the code comes from bugs actually being in the big computers. Apparently that is urban legend and not true. So, yeah, I was so disappointed. I'm like, oh. I'm like, I always knew that question when people asked it, but apparently it's not true. But we squish the bugs, like we squish bugs. So profiling is getting your code to run faster, finding out why it's slow, what's going on, and being able to find the bottlenecks in your code. And so I take things really laid back, really hands-on approach. So I don't want anybody to feel like they can't get up here and present something that they've been working on that they think is cool that other people might like. I do that kind of stuff all the time. I want everybody to feel like they are comfortable doing that. So if this is a little bit less formal, that's why. I don't want to send any. If I can get up here and do this in front of everybody and record it for posterity on YouTube, anybody can do this. So let's get into it. So I am going to share a simple thing that I've been working on. How many of y'all make tables for your work out of R? How many of you work with people who insist on having tables in Excel? So there are some wonderful packages out there. Openxlsx is wonderful. The Xlsx package, which is based off of Java, is fabulous, except that it's based off Java. And so it's half the time unusable. Yeah.
Do you have a guest Wi-Fi password?
The guest Wi-Fi is, so the Newmont guests, and then I think it's welcome to Newmont.
Yeah, welcome to Newmont.
So yeah. So yeah, so let's take a look at the code. You can get the code, or at least the bad version of the code, from the files portion of our website. So sites.google.com/site/utahrug/files. And then it's xlsx.r, and I think that all of my files, all of the definitions that I need are in there. And then there are a couple of libraries that you'll have to install as well. The most important being the Openxlsx package, which is what this is based off of. But if you'd like to follow along, go for it, because the xlsx.r that I uploaded to the file has some bugs in it. So we're going to try and figure those out today. And I will walk you through the kind of debugging process that I go through when I'm trying to track down bugs and fix a function. So first we need to know what this function does. So we've already got the write.xlsx function that puts out a table into an Excel file. But I'm really lazy and I want to do things once, and I'll create a file and then I'll format it nicely, and then I've got to fix that one thing and go back and keep going through and formatting it again to sending it to people, and they're like, oh, got to change this, got to change that. So what XLSX does is it does all of my formatting automatically. Namely, it will create a table that looks like this. So we have columns merged. So this is a header portion of the data, and it's multiple rows with the headers spread across. So you'll have a column like I'm actually going to pull up a better example. Oh, you'll have a column with subcolumns and then even more subcolumns. And so what it does is it takes the headers in a standard format. You break on periods. What underscores are translated into white space, and so you can create your variable names in legible syntax for R, but then it automatically translates to something nice for a table. So here we have a B, sub 1, sub I, and then a column. Also, in the rows, so I'll do groupings like I work with the VA data, so I'll have branch of service, and then I'll have a subcategory of were they an officer, or were they enlisted, or were they a warrant officer within the Army or within the Air Force. And so they'll have those subcategories as the second column. And so it merges down this cell on these columns. Does that make sense? But then it also adds borders. We have borders for if it's a merged column, it will add borders down and borders across for merged cells, so that we can kind of get sub cells to make things easier to read and stuff.
With all the subgrouping and categories, that's all optional. What if you just want to go raw Excel dump?
You've already got that.
You
want a raw Excel dump? You can just use write.xls. One reason why I would use this is because I also do some easy, lazy shortcuts for it. Automatically saves. So I've got several functions in here. So if it's Excel, I can put like 4 tables in there. Whatever the name of that first table is, it will say assume that .xlsx is the file name for the file. So I don't have to specify the file name when I know that I want to output this object, then go look at it, go back and forth and back and forth. So yeah, the point of this is debugging. how do we fix the problems? If we go in, we're going to start in R, and then we're going to move to RStudio so that we can see some of the differences and the nice things that RStudio adds to things. So we're going to go in our demo here. We're going to load up all these extra packages that we need or we are going to use today. The tidyverse, assert that I use. If you're not familiar with assert that, it is like parameter checking. Regritter for the pipes. We'll see lots of pipes today. Per for functional computations. Test that for unit testing of our code. And dplyr for our data manipulations that we'll use in our profiling data. So the first thing we want to do, source our Excel file. And everyone familiar with the Iris data set? Go Iris. So we've got sepal length, sepal width, petal length, and petal width. Those look like they're subcolumns. Good example for our Excel function, huh? So let's try it. So we got, and it doesn't work. So actually, that error should not have happened quite yet, but okay, so that doesn't work. So what's going on? Let's dig into the code and see if everything is working the way that they're supposed to. Who writes unit tests for their code? 2 people. This should be a lot more. So proper programming is test.
That's why we're listening to you.
Yeah. So unit testing. If you don't know unit testing, use test that. It is a fantastic package. Comes out of the RStudio people, and very soon you can use the documentation package when I get around to releasing it. That will pull out the testing data, testing blocks that you can put in your code. So here is a testing block that says, the if false just says, don't run this when you're sourcing the file. But this is a testing block so that when you're going through your iterations of development, you just say, all right, copy, this is the function I'm working with, and run through these and check. And all the test that is this kind of expect is style2 is a style. So expect style2 is a style. Expect that these two are not identical, and so forth. Did I see questions? Sorry. Okay, so we're going to jump down to the main function here, which is our add sheet. This is where the bugs are. I know, because I put them there. So we're just going to check. So looking over the code, we have input validation, so our assert that. Make sure that Openxlsx is available. Make sure that what's coming in is a workbook object. Make sure that name is a character, all of that stuff. Then we go through, write the data, merge the cells together, set the style for everything. And then return the workbook. So you could actually chain, add a sheet, add a sheet, add a sheet, add a sheet together in a call. So we're gonna construct our toy data frame that we're gonna work with. And so this is the workbook that I showed you earlier. A, just letters, and then we have the B variables, B variables 1, B variables 2, I, double I, and C1 and C2 to make sure that all the headers work together and everything, and so it does exactly what we want it to do when we want it to do it. What happened? Okay. Save that then. Why? That's the first time that it's done that for me. Yeah, of course, it works fine, and then when you get up to present, it decides to break on you. Okay, this is. Oh, we go to the help files because. Maybe we need to put in the unest z. Got it? Any ideas?
Show me what's after. Show me X again.
So X is A, B, B1I, B2 double I, and Z. And Z is supposed to be.
Let's see. Ungroup it first. X ungroup.
Ah. Did it like that? It like that. Thank you. All right, so now we've got X. We're gonna ignore this for a minute. Okay, now we're gonna say, okay, we've got a worksheet object, now X. Okay, so we've got conflicting merge cells, which also should not have happened. Okay, so we've got our first error. What do we do? Well, we can step through the code. The first thing is our recover option. So when you have an error, R will decide, what should I do? The default is to just print that error out and break and stop. You can also have it just quit R completely. But the thing that's really useful is saying we want to recover. What recover does, we go in. All right, now let's try it. Okay, so we are in add sheet, add worksheet, WB name. So let's see where we are in add worksheet, because that's one that we wrote. That's where we are. Okay. So let's check what's there. When I was originally developing this, I was having trouble tracking where I was in things. So I actually added just dummy variables in here to say, yes, I have passed this step. Yes, I have passed this step, just to say I'm done with merges, I'm done with written, so that when I went in to check things, I would know what step I'm past. But it doesn't look like I'm past anything here. So it's step 250, line 257. So we are right at the very first thing. So WB, what is WB? Okay, so it's already got an object X. So if you want to quit the browser quickly, you do Q. Go, all right, what is WB? WB has a worksheet X and it has 2 columns. Oh, we don't have a create workbook. So let's check what WB is before it goes in. Okay. So it should not have anything. and it still has problems with merging cells. So let's debug it. So debug once or debug. We're going to debug once, add sheet. Then run it and say, okay. So now we're in the browser again, same way that we got to the same place from recover, but now we can step through the code. So we can do next or just press enter and go, okay, step through. So our assertions, we got through that. Now we're on to add the worksheet. This is bizarre. Worksheet by that name already exists. So we're gonna step into the one. Nice. This is not going the way I planned it. Okay, so create a workbook, step in. First thing we're going to see is WB. It does not have any worksheets attached. It should not have any worksheets attached. So go through, still no worksheets. So add worksheet, WB, no worksheets attached. Name is X, which is what we expect it to be. That's the name of our object. Okay, so now write data. Write data. So we've gone through written. Now we're now to our merge section. So we're right here in our merges. Oh, did we? That's actually good. And so if you're in a loop like this, you can press F to finish the loop, and then it'll go to the next. Hey, there we go. Yes, F or C, but F is better to finish the loop. So you just go through, and now we're on 294. So set the widths. Okay, finish the loop. Now we're done with merges. Now we're doing borders. Okay. Now we're back to where we should be with the problems. So we're on number 311. So let's see where we are. So we're done with merges, we're done with written. Now we have, let's see what MD is. No merging down, no merging, we do have merging right, so we should be merging across. So merge cells. Well, let's check out WB. This is one of the things that you're going to have to do is when you debug, you have to dig into other people's code. So WB is a workbook. Let's see what merge cells says. Merge cells just goes into the WB merge cells function. I'm going to shortcut here. And so we're looking for the merged cells object, which should be under here. Okay. We're going to actually load up the Ifelse package. If I could spell. And I clearly can't. Let's merge. So apropos is a search function in R that will tell you all the functions that are that match that phrase. So merge exports, merge import methods, merge cells, merge styles, remove cell merge style. It's a cool thing to use if you're on Linux. Apropos is a command line for finding things, and it works in R the same way. So it does it case insensitive, and it shows you all the size, all the functions that match that phrase. So let's go with merge. I'm going to look in here and say, okay. Oh, so we have to go into the worksheets, merge cells. So WB worksheets, there's only one worksheet. So here are all the merged cells. I don't know why they're already merged at that point, because they should not be. That's not. Yes, that is actually one of the problems that I introduced. I just did not introduce it there. So that is one of the problems I introduced. I wasn't expecting it to come up here. So actually the problem is we have, but let's step into that again and I can explain it better. So here we are, we're gonna go into the merge cells function, see what's in here. We've got, all right, end row 1 and column is 5. Start column is 3. So we're trying to merge columns 3 through 5. However, looking at VB worksheets 1, merge cells. We see under row, we're looking for row 1. Oh, we have A1, or we have B1 through E1 already merged. So we're saying we want to merge C through E, but B through E is already merged. That's not right. Why is that happening? That's the question of debugging. How do we figure out that is happening? Well, let's take a couple steps back and say, go up a level. So now we're going to go to the second level and say, all right. Oh, we actually need to go up. Columns and rows, we could get that same information there. Go up another level, go up to 1. Okay. So if we're right here, is that where we were? 311? Oh. Right here. So let's see. Okay, where are we? Row, column. All right. So there shouldn't be anything at row column. So our merges down will tell us our header. So in our header, where we create the header is up here in this compute merge columns. And so when we accumulate back, so the way that it works, we step here and we go backwards. Is this, when it comes out, is this the same as that? Yes, it is. So accumulate, so merge those together. Are these together? Yes. Are those the same? Yes. And so it keeps accumulating. And so it says, this is merged. So how many cells to the merge to the right? 0. 1. 1, 2, but then this still says 1. And this says 4, but this still says 3. So what we need to do is say that right here. What we're going to do here is we're saying after we accumulate it and add it up, just throw away what was in that cell, because we don't want any values, we don't want any attributes which is what we're using to accumulate that, keep that tally of how many cells to merge. So save it. Right. And now I'm going to come back here, source it again, and go to does it right now. Oh. I have to define a new worksheet. Ah, now we got another one. This one is the one that I intended to be our first one. So this is the bug that I intended to be first. And this is one of the things that is very common is, oh, it can't find a variable. It won't catch it in parsing, but it will catch it when you actually try to run the code. And this one is much simpler to find. So we're on in our now that we have our recover on, it says we are at xlsx.r line number 349. So we go to line 349, and right here, these. So this is where I copied out and said, okay, we're going to get the style from the workbook, the worksheet, the row, and the column. But sheet is not what we're using. We are using name for the name of the worksheet. And so all we have to do is replace those with name. And now it should print, or now it should write out. Now does it work? Now does it write? Yay, it wrote! All right. Did it do it correctly? Let's jump ahead and say if we so there are 3 levels of functions. So the add sheet is the one that does is the workhorse function that does all the heavy lifting of adding things. And then Xlsx multi-line is one table to one file. And then my Xlsx function is multiple tables to one file. So if we go to our multi-line, you can see all it does is it's just a wrapper around add sheet that adds the file name and writes it out. Okay. Now there should actually be a couple of problems in here. That I am not seeing some of them, but I'm gonna proceed on. So this the step is to look at the output and say, is the output what I want it to? It's not supposed to be. It looks pretty good, but we're gonna pretend it doesn't look good, and we're gonna go in and double check. So that's where the unit tests come in. Now we're gonna switch to RStudio because that makes things quite a bit easier. So here we've got our Xlsx file. We've got our demo file here that we'll come back to in more detail later. That is really, really tiny. Let's see. And one of my annoyances of RStudio is that it likes to freeze on me. Okay, moving on. We'll come back and see if RStudio decides to work in a minute. Oh, maybe? Okay. We're going to step through these, all the unit tests, make sure that it does what it's supposed to do. Let's make sure that we've got. So one of the nice things that RStudio has is it has this source on save. So if you're dealing with source files for functions and stuff and then using them later in another file, it makes it much easier to just save it and rerun it. So whenever you save it, it will. Let me make sure that this is, because we made a couple changes in the other one. Okay. Let's make sure it runs still. We didn't overwrite our. So check, make sure that the sheet name's correct. The things there, that the data matches. There's only one style for each cell. And the borders. Oh, there we go. There we go. So our border bottom is not equal to expected. So if we can figure out what that is. Oh gosh, is it 12:45 already? I need to move faster. I'm sorry. One of the bottom borders on here is not correct. So we would go in and track that. I'm gonna take, and I actually know where it is, but I'm gonna show you these things. So you're gonna add breakpoints into functions and tracing. This is much more useful than the debugging function or the debug once function, because this lets you do almost anything. It lets you do reference class methods. It lets you do methods in period, which is a lot better. So the S4 methods, it lets you debug those, so you can add a signature and say, I want to call add style only when it's a workbook and a list, or instead of a style class or something like that, so that I can get to that specific class. And what I would show you here is, first you can set a breakpoint. That says, in my code, I want to set a breakpoint. It's a lot easier to do in our studio. If I want to set a breakpoint, I go in here and I click and set a breakpoint. So that when it sources it, it will have a breakpoint. Our studio makes it a lot easier that way. If I'm doing it without our studio, I would use set breakpoint, but I also may use trace. Here I am doing, I want to debug add style, because I use add style all the time. But I only want to call it when I am at the row 6 and 5 in columns. So row 6, column 5, and that my style is not, that my border left style is not null. That's the only time I want this to call. And so what it'll do is it'll say, okay, go in, I'm entering add style. Check this, is it true? No, go on. But when that is true, it will break it just like the recover function and let me go in and check, okay, where did it get called from? Where did it, why is that specific cell giving me problems? And I know why, but I'm gonna skip over it in the interest of time. Oh, dang it. I pressed a button. Okay, good. Another one that you might do is say, okay, I want to go in and to add style when it already has a style, and that's a function that I created. Let's go on to profiling, because I think that that's an interesting thing. So I'm going to go, I will upload the good version after I'm done here so that you can see it. We're going to go good, and we're going to use profr and ggplot2. There are several packages out there for profiling. Profr is the one that comes from our studio that is actively maintained and updated. It's a very good package. Prof Tools is done by the R Core, which is also a very good package to use when you're dealing with prof data. Profr provides the function profr that lets you profile a single call and pull it out as data. So here we're writing our iris data set to an Excel spreadsheet, and it's taking a while. And that's what we want to find out, is why is this taking so long? It really is not that complicated of code, but And if we're doing a lot of these, we want to figure out why it's slow. It's not that important of a function that I would spend a whole lot of time profiling this, because it's not called that often, but it's for demonstration. So down here, we're overwriting the workbook. And when you're presenting, it always feels like so very long. You're developing it, I'm like, okay, yeah, it takes about 20, 30 seconds. And
it does it a bunch of times, right? It doesn't just call it once, like
what it does is it actually inserts extra code in there that it takes snapshots of the code.
Yeah.
Like every 2 milliseconds or something like that, and it takes snapshots of where the code is running, and that's what's adding all the extra time of when we're running it. So let's check out the P data. Okay, that's a lot. So we're gonna use the pipe, and we're gonna make this a tibble so that it's easier to look at. So we've got our level, how deep in the call stack we are, GID, TID, which is I think the group in the time or something like that, and then the function that you're at, the start time, the end time, and this is the real important one, is the call time, the total time, the time that you're in that function. So in the Excel function, this took 42 seconds. But let's look at that. Actually, I don't need to pull up the plot because it's already up here. And it doesn't tell us anything relevant at this stage. So let's do some summary of it. What we want to do is look at, okay, how deep we are at each level, what's the total time broken up? Because on one level, so if you're 3 levels deep, all those functions should be exclusive and not cumulative. So let's group by our source level and summarize for the total time. Okay, Openxlsx, add sheet. Those aren't telling us anything. What we really want to do is we want to be within. We know that that add sheet is the workhorse. That does everything, so let's filter down to that. Also, we're going to arrange it by our time, because I'm not interested in the order that they come in. Okay, this is interesting. We are spending a lot of time in eval, and we're spending a lot of time in our pipe. I don't know why it says it comes from test that, because it doesn't come from test that, it comes from Magritter. But we're also spending a lot of time in adding borders. Why are we doing that? Another way to look at that is with the profviz package, also by RStudio. But it gives this nice sheet. And I'm going to go. Okay, I'm making it big as I possibly can. This is really cool. What this does is it tells you in that call how much it puts your sheet here. It says how much am I spending on each call. That's concerning. It's spending a significant amount of time in pulling out the field names. I don't know why that's so slow, but we get that's one target for speeding it up. I actually know why it's slow, but we're gonna pretend. Okay, so here we're spending a lot of time, and that's because we're already identified we're in field names. Spending a bit of time in merge styles. Spending a lot of time here in computing whether we have the right row or the right column. And this is an artifact of dealing with Openxlsx because it's reference classes. It stores a list of references that and then you have to go through each of the styles and say, is this the right style? Is this the right style? Is this the right style? Another way that I could design this package is to stack the styles on top of each other instead of having one style per cell. This is the way I decided to go about this, but I may refactor it, which is what it's called when you take a function and say, you know, I'm going to start redesigning this function and say, I'm going to do it from the start and do it with a different design. That's refactoring code and saying, can I write this function in a different way to get it faster or get it more accurate or something like that.
What's the graph at the bottom telling you?
Oh, good question. Let's zoom in.
Oh my. Wow, really?
Head border and border, pipe. That's one of the problems with the pipe not being built into R, is that you get these kind of things that come up. And there is, I have written but not released code to kind of mitigate some of this stuff. But what you want to do is you want to kind of, all of them are pipe, eval, and then you want to squish those down. Oh, and freduce in there. That would be an freduce kind of thing. And then you just want to squish those all down and bring everything down to one level. But that's what the other thing that we can see clearly as part of the time, which is usually what the case is, right there. The writing, the actual file input output, that's always one of the very slow things on a program, which we expect. So this is what you do to go in and investigate. Why is this section going in? Let's take a look at this beginning part. So here we're getting merged styles, and this is one of the ways where it's saying, okay, I'm taking multiple styles, so border left, border right, and combining them all into one thing, and it's using, and this $sign operator is taking up a significant amount of time as well. This is what I would go in to look at and say, okay, is there any other way that I can do this? One of the ways that I might do this is to say, I am only dealing with straight up lists. I am not dealing with reference classes. Everything is a list until the very last possible moment, and then it creates a style, which would be much faster because the $sign operator on a reference class is much slower than the $sign operator on a list. That's one of the reasons why this is slow, almost intentionally. The pipe operators add time to it, but they are not the significant time waste that the $sign for reference classes is. That's the real culprit in the slowness of the code is right there, is that $sign operator. And there we go. So we are right about at an hour. I'm sorry, that went slower than I thought it would. I want to show you a couple other things that you might be interested in. Yeah, we'll reload it. So there were some comments about pipes. Pipes are one of the special infix operators that you can create yourself if you would like to. Here are a couple of the infix operators that I use regularly. %if for a postscript if. Yeah, it's cool. So when I use those, I'm coming down here and saying, so this is the merge styles command. So my header style, so take the header style, add a top border if the row is the first row. Add a bottom border if the row is the bottom of the border. Left if it's the leftmost column, right if it's the rightmost column. So it just says, it's just kind of it's a more legible version, and I also have a version that has a if else with a postscript else that just help the ease of readability. I picked that postfix if from programming in Ruby, and I'm like, that is really, really useful. And when it doesn't evaluate true, it just returns a null value, which in many cases is just ignored. The percent slash, and that one's actually interesting because when you write it in code, it will be it's a so if you can't see, it's a single slash, even though it's defined with a double slash, because you have to escape it when you're putting it in the name. A double pack and a triple pack infix. So this says, okay, paste it together with a space, paste it together without a space. And what this does is it lets me take long messages and say, okay, pack it all together in a single line, like a C++ operator that does the same thing for strings when it's overloaded that way. Another one, so if you want to write your own, we'll go % not in % backtick. Those are backticks, the thing that's under the tilde. And then not in let's see if that works. So then let's go 1 and not in 2 through 3. Hey, it works. So we were talking about infix operators earlier, and I said, hey, you can do that yourself, and it's not that hard. Yes. The problem is when other people have the same idea, they do it differently. And then you're like, oh crap, they put it in a package that I now use, and it doesn't do exactly what I expected it to do, which I come across all the time. But okay, questions about profiling. Let's make sure that we get your questions answered. I'm not sure how long we have the room for, or how much. It looks like there's actually somebody in the hall.
Yeah, I think they do have a class. So, yeah, let's take a couple questions and then we'll maybe move out and have a discussion. Any quick questions before we start wrapping up?
I do have one more thing on our studio.
Okay.
Debugging and profiling. You can actually start and stop profiling from there and do the profiling. The profiling is in our studio is nice because it has the Profviz built in, and it has it all built on Shiny and HTML widgets and stuff. And so a lot of that infrastructure is already here, which greatly helps out.
That's what I mostly use. And it's pretty easy to get going on. Thank you all so much for coming. I will hang around out there and say hello. If anybody has interesting things they'd like to share in an upcoming meeting, let me know, and we will we
Yeah,
wanna
this was
say
just something
more,
that I was
thank you.
working on, so you guys can do it too.
Yeah, yeah. Thank you all so much for coming. We will look for you all soon.